I am Dr.J.Vinnarasi, Assistant Professor of Chemistry, the Standard Firex Rajaratnam College for Women, Sivagasi. Today, we are going to see how the geometry of the molecule predict using hybridization. There are various methods are available to find the hybridization because in competitive exams, the one question is asking about the geometry of the molecule. The learning objectives are predict the hybridization. Using VB and VSCPR theory, we can predict the geometry of the molecule. Next, we have see some problems, then summary. First of all, we see about what is hybridization. A nutshell point is mixing of atomic orbitals with similar energies and they form equivalent number of new orbitals of identical shape and energy. This is called hybridization. The new orbitals are called hybrid orbitals. A few points for understanding the hybridization. The number of hybridized orbitals generated is equal to the number of atomic orbitals that is participated in the hybridization process. The second one is it is not applicable to isolated atoms. Third one is the covalent bond is polyatomic molecules are formed by overlapping of hybrid orbitals or hybrid orbitals with unhybridized one. Next, we see the first method to predict the hybridization and find the geometry of the molecule. The first method is the formula or the regions of electron density. We calculate from electron density. So, R is equal to number of bond plus number of lone pairs. A very simple formula, we can predict the hybridization. From the hybridization, we can find the geometry of the molecule easily. So, what is meant by R? Count the number of valence electron in the central atom. Determine the number of bonds. Then count the lone pairs present in the atoms. For example, what are the types means? R is equal to 2 means that is sp hybridization. The geometry of the molecule is linear. The bond angle is 180 degree. Then electron density R is equal to we get 3 means the hybridization is sp3. The geometry of the molecule is trigonal planar geometry. The bond angle is 120 degree. Then R is equal to 4 means sp3 hybridization. The geometry is tetrahedral. The bond angle between the atom is 109 degree. R is equal to 5 means sp3 dehybridization. The geometry is trigonal bipyramidal and the bond angle is 120. The R value is 6 means sp3 d2 hybridization. The geometry is octahedral and the bond angle is 90 degree. For example, we see with one example. For methane, the valence electron is 4. The number of bonded atoms are 4. The lone pair present in the molecule is 0. So, the first simple formula is R is equal to number of bonds plus number of lone pairs. So, there are no lone pairs present in the molecule. So, 4 plus 0 is equal to 4. The R is equal to 4 means the hybridization is sp3, the geometry is tetrahedral, the bond angle between the atom is 109.4 degree. The second method is usual method. So, H is equal to, H represents the hybrid orbitals. The H is equal to half is equal to number of valence electron of the central atom plus number of monovalent atoms surrounded by the central atom plus or minus. For example, the charge of the cation means we have to minus the charge of the cation. If the molecule having the anion means plus charge of the anion. So, H represents the number of hybrid orbitals. Next, we have to calculate the number of valence electrons, the number of monovalent atoms attached to the central atom. Then, we have to find whether the molecule contains cation or anions. For example, methane. So, number of valence electron is of the carbon is number 4. Number of monovalent electrons present in the molecule is 4. So, we have to calculate there is no charge for this molecule. So, H is equal to 4 plus 0 divided by 2 is equal to 4. So, number of hybrid orbitals is 4. The geometry of the molecule, hybridization of the molecule is sp3. The geometry of the molecule is tetrahedral and the bond angle is 109 0.5. The steric number is used to in VSPAPR model to predict the geometry of the molecule. The formula is steric number is equal to number of valence electron present in the central atom plus number of atoms bonded to the central atom, whether the molecule having a charge. So the charge on the cation minus charge on the cation and plus charge on the anion divided by 2. For example, the same example, methane, we have to predict the geometry of the methane. For example, carbon is the central atom in the methane molecule. So the valence electron present in the carbon is 4. Number of atoms bonded is 4. There is no charge on the molecule. So the charge of cation or anion is 0. So we have to apply in the formula steric number is equal to 4 plus 4 divided by 2 is equal to 4. So thus the hybridization of the molecule is sp3. The geometry is tetrahedral. Similarly, we have to predict some other examples. For example, ammonia. For ammonia molecule, the nitrogen is the central atom. The valence electron present in the nitrogen atom is 5. Number of atoms bonded to the ammonia molecule is, there are 3 hydrogen atoms, so we put 3. Then the charge of the molecule is nil, so 0. So steric number is equal to 5 plus 3 divided by 2 is equal to 4. Thus the hybridization of the molecule is 4. The geometry, the hybridization is sp3, but the geometry of the molecule is not tetrahedral, but it is a pyramidal. Due to the lone pair present in the molecule, the geometry expected as pyramidal using VSCPR theory. If we have no lone pairs, we use the VP theory. If the molecule contains lone pair, the geometry must be predicted using VSCPR theory. The another example is bromine molecule. For example, Br3 plus. So the central atom is Br. Even though 3 atoms are same, so we use one atom is central atom. For example, the valence electron present in the bromine is, this is a halogen family. So the valence electron present in the molecules, for example, fluorine, chlorine, bromine, iodine, whatever the atom, the valence electron are present in the atoms are 7. So next, the number of atoms bonded to the molecule is 2. The charge of the molecule is plus. So we have minus the charge. So the charge of the cation is minus 1. So the steric number formula is equal to 7 plus 2 minus 1 divided by 2 is equal to 4. So we get a steric number 4. The hybridization of the molecule is sp3. The geometry is tetrahedral. Next, we have see some examples from noble gas. For example, xenon compounds. The first example is xenon difluoride. The central atom is xenon. We know that the xenon molecule is a noble gas. So the outermost configuration or the valence electron must be 8 for all the noble atoms. For example, neon, xenon, krypton, radon, etc. So the valence electron present in the central atom is 8. The number of bonded atom is 2. The charge of the molecule is nil. So we have to apply the formula. Steric number is equal to 8 plus 2 divided by 2 is equal to 5. Thus the geometry is linear. The hybridization is sp3d. According to hybridization, the geometry actual geometry is trigonal bipyramidal. But due to the lone pairs present in the molecules, there are 3 lone pairs present in the molecule. So according to VSCPR theory, the geometry is linear. The second, one more example, xenon tetrafluoride, the valence electron is 8. The number of bonded atom is 4. The charge of the molecule is nil. So we have to use the steric number formula, number of valence electron plus number of bonded electron plus number of charge divided by 2. So 8 plus 4 divided by 2 is equal to 5. So the steric number is 5. The hybridization is sp3d2. According to the geometry VB theory, sp3d2 hybridization means the actual geometry is octahedral. But according to VSCPR theory, the geometry we get is square planar. So next we have to summarize all the concept. For example, without lone pair, we get the geometry. The steric number is 2. the geometry is linear. Then the steric number is 3, trigonal planar, then tetrahedral, then trigonal pyramidal, while the steric number 6 means octahedral. We have to, one or more, the molecule contains one or more lone pairs means the according to lone pairs present, the geometry may be differ. For example, the steric number is 3. The lone pair is present means there are one number of lone pair present means the geometry is bent or angular. For example, now we see there are 3 number of lone pair. The steric number is 5, but there are 3 number of lone pairs present in the molecule. So the geometry is linear. So now we conclude the methods. Now we see the 3 or 4 methods, but the simplest method is the steric number method, because we know the atom, so we have easily find the valence electron, number of bonded electrons, then the charge of the molecule, then we have to find the hybridization and find the geometry of the molecule. So this is the simple table which represents the geometry using hybridization. Without lone pairs, the geometry is predicted by VB theory. If the molecule having the one or two or three or more lone pairs, we have to use the VSCPR theory to predict the geometry. For example, the steric number is 2. Without any lone pairs, the geometry is linear. The bond angle is 180. The steric number is 3. Without lone pairs, the geometry is trigonal pyramidal. The bond angle is 120. But we have one lone pair present in the molecule means the geometry is angular or bent using VSCPR theory. The steric number is 4. Without lone pair electron present in the molecule, the geometry is tetrahedral. But we have one lone pair electron means the geometry is trigonal pyramidal, and the band angle also decreases to 107. But if we having two lone pair means the geometry is bent or angular. We having the steric number 5, but we don't have lone pair means trigonal bipyramidal. But we have one lone pair means the structure is seesaw. There are 2 number of lone pairs means which is T-shaped. We have 3 lone pairs means which is linear in structure. The last one, we have steric number is 6, but no lone pair present in the molecule means the geometry is octahedral. The bond angle is 90, but there are one lone pair is present. What about the geometry means? The geometry is square pyramid. There are 2 lone pairs means square planar. There are 3 lone pairs means T-shape. There are 4 lone pairs means the geometry is linear. So using various methods, we have to find the hybridization. If we find the hybridization, the geometry is easily found by VB theory or VSCPR theory. For more modules, visit www.sfrmlearning.org. Thank you.